Do you guys know how to use this board?
Yes. Okay. So I'm Shaza.
And I'm Jamie.
So we will be demonstrating to you guys how to activate and deactivate the LEDs on this board, and also how to use the RGB LEDs and also the 7-segment display.
Stay tuned.
So before I explain the code of each task in details, let me explain few important functions in this code. So the first one is display function. So in this display function, we need to specify which task we are going to do on the LCD screen. It depends on the input from the user. Next, we move on to the initialize LED function. So in this initialize LED function, we need to initialize for all of the LEDs, which is LED 5 to LED 8. So we need to set the GPC 12 pin to the output pin. So same goes to 13, 14, and 15, which is the LED 7 to 8. Next, we need to set the GPIO pin to output low, which means that the GPC 12 pin output is high, which is set to high to turn off the LED. So all the 4 LEDs are turned off in this stage. Next, which is the initialize for RGB LED. So same goes to the RGB LED. We need to initialize it first, which is initialize the GPA pin 12, pin 13, pin 14 to the output mode. After that, we need to set the GPIO pin to output high so that it can disable the LED, which means that we turn off all 3 RGB LED. So this video is divided into 5 different tasks, which is saved in different functions, which is function A, function B, function C, function D, and also the 7-segment display. So we now go through the main code. So at first, we initialize the character where the lab task demo, which need to be shown on the LCD screen. Next, we initialize the LCD and clear the LCD. So after that, we initialize the 3 keypad and we print the text 0, which is lab task demo. So in this loop, we will try to get the input from the scan keypad. So if user input 1, so it will go to display 1, which means that it will show that it is a lab task 1. So in task 1, then it will initialize the LED. Then we will go to function A, which is we need to illuminate all 4 LEDs. So in function A, we turn on LED 5 to LED 8 together at one time. So this output low to turn on all 4 LEDs, which is from the GPC pin 12 until GPC pin 15.
Okay, so for the first task, we need to illuminate all the 4 LEDs on the board. So when I press 1, all 4 LEDs are light. So from LED 5 to LED 8.
So when the scan key detect number 2, it will go to this loop. So the LCD will display is a LED task 2. Then it will initialize the LED, where all the LEDs will be set to turn off. So it will go to function B. Function B is where we need to illuminate all the LEDs alternately. So in this function, you can see that we output low for GPC pin 12 to turn on the LED 5. Then we set output high to turn off the LED 5. Same goes to LED 6, LED 7, and LED 8. So the LED will turn on alternately in this function.
So for the second task, we need to illuminate each LED alternately using a suitable delay. So when I press 2, the LED 8, 7, 6, 5 will blink out alternately.
Next, if the scan key detect number 3, so it will go to this loop. So it will display is a LED task number 3. So it will initialize all the LEDs where all the RGB LEDs are turned off. So it will go to function C. Function C is where all the RGB LEDs are turned on alternately. So we can see that GPA pin 12 is blue color, GPA pin 13 is green, GPA 14 is red. So we will start off with setting RGB LED to blue, where we clear the GPA pin 12 and we set both these to high. Same goes to RGB green and also RGB red. So the RGB will turn on automatically from blue, green to red. Then it will turn off.
So for the third task, we need to illuminate all the RGB LEDs alternately using a suitable time delay. So I press 3, so the RGB LED will light up from blue, green, red.
So for the fourth task, once you click number 4 or you press number 4 on the keypad, it will go to this segment. So when you press number 4, it will display number 4, task 4 on the LCD display. And this is where we initialize the buzzer to open up the buzzer to use the buzzer. And it will go to function D. So at function D, we'll be returning number 5 so that the buzzer will buzz 5 times. So it sends number 5 to function D, which will be placed inside the integer I. So for I equals 0, I less than 5, I plus plus, it will be in this loop for 5 times. So this part right here, it turns on the buzzer, clear bit, turns on the buzzer, and there'll be a delay. And this part here will turn off the buzzer, there'll be no delay. And after it exits this for loop, it will go inside the loop again for another 4 times. Okay, so for the fourth task, you need to activate and deactivate the buzzer labeled as BZ1 here using a suitable time delay. So we just pressed 4 and it will buzz. So for the last part, which is the task number 5, where you need to display 0 to 99 on the 7-segment display, you will press number 5 on the keypad on the board, and you will see that on the LCD display it will say that it's that task number 5. So this is the important part of the code or in this segment. So there's 2 while loops. So this while loop here, it ensures that it repeats until 0. Since we're trying to display 0 to 99, it needs to repeat until 99. And inside this while loop, there's another while loop that helps to ensure that display, since I'll give you an example. So if we're trying to display the number 19, 1 and 9, so I'm going to call number 9 as the positional number of number 0 and number 1 to be position number 1. Okay, so position number 0, what happens here is that we're trying to ensure that position number 1, which is 1, will keep on displaying even though position number 0 changes from 0 to 9. Okay, so this is why we need this while loop. So here we're going to go to the segment underscore display function. Okay, so in here, let's say the value that we get from our I, or from I, let's say it's, I'll give you an example, 25 here. Okay, so the digit will be 25 divided by 10, that means 2.5. So the digit that will be saved, the number that will be saving to digit will be number 2. Reason being is because we're trying to show the positional number 1 into this digit. So we're trying to display number 2
inside position number 1, since we have 4 7-segment display. So 0, 1, 2, 3. So number 1 will display the digit number 2. And then it closes 7-segment and then it shows the number 2, and there will be delay. The next part, which is for the 7-segment number 0, we will try to display number 5. So what we do is that we minus the value that we have previously, which is 25, to get the new value. So the new value will be 25 minus 20 equals to 5. So the digit now will now be number 5. We'll close 7-segment and it will show number 5 at the position number 0 on the 7-segment display. And then this is just a delay. We make it really fast so that you don't see the blinking of the blinking of the LED 7-segment display. So once you're done with that, it goes back to here where there's an increment of I, where since previously it was 25, it will now be 26, and the loop goes until 99. So this is how you display the 7-segment part. And once it reaches 99, we set it, this is optional, but we close the 7-segment and we show at the position number 1 of the 7-segment, we show number 0, and we display on the position number 0 on the 7-segment the number 0, so that it displays 0, 0 on the 7-segment.
Right, so for the last task, which is task 1B, we need to display the number 0 to 99 in continuous incrementing sequence on the 7-segment display on the learning board with a time interval of 1 second between numbers. So you pressed 5 and you will get 0 to 99.